Hello students, welcome to this presentation. Today we're going to continue our path about talking about food microbiology, and in this case we're going to talk about food safety and sanitation. So we're talking about food microbiology and food safety and sanitation because we want to prepare for our fourth week, which is food processing. And if we think in like a general aspects of food processing, so we process foods because we want to add value to the foods, we want them to last longer, and to do so we have to inhibit or inactivate microorganisms. And we have been talking about the good microorganisms, which are the ones that we use for fermentation. So in this case, we want them to grow under specific conditions, and we want them to produce specific products. But in order for them to do so, we have to be very conscious about the sanitation of our process. And in some cases, when we talk about the bad bugs or the bad microorganisms, we want to inactivate or inhibit them. And we can do that through food processing. So let's take a look at food safety and sanitation. So the objectives for this presentation are to identify the types of hazards, to discuss what happens when things go wrong, to distinguish between food quality and food safety, to explain the food safety objectives, to define GMPs, define sanitation SSOPs, to explain HACCP, explain FISMA, and to discuss food safety in the home. So when we think about a hazard is any biological, chemical, or physical agent that has a potential to cause an illness. And we can see this table here, and we have the classification, which is biological, chemical, and physical. So if we think about examples of biological hazards, we can have bacteria, virus, and parasite. If we think about examples of chemical hazards, we have pesticides, environmental industrial chemicals, like cleaning agents, sanitizing agents. Also, other examples are like animal drug residues, hormones, antibiotics, heavy metals are other examples. Mycotoxins, which are toxins or aflatoxins produced by fungus. And we can also have chemicals like allergens or food additives to which consumers have a sensitivity. And talking about physical hazards, we can say sharp objects like metals, glass, plastic, bone chips, insects, or choking hazards. So HACCP, which is one of the quality system, is based on identifying these three types of hazards in a food process. So what happens when things go wrong, and what do I mean by that? So there has been a long history, things that have happened to consumers. And for example, in Kinder Surprise, there was a lawsuit. U.S. customer was sued the company because the chocolate eggs contained toys that were considered choking hazards. So these type of products are mainly consumed by kids. And if these toys have a potential to be a choking hazard, well, this is a hazard that the company has to consider when manufacturing these type of products. Another example of like when things go wrong is when there was a conference, a food safety conference, and there was an Clostridium perfringens, which is a bacteria, and it was present in a chicken dish. So maybe that dish was not cooked properly, maybe there was a contamination, so we don't really know, but 260 individuals were sick and at the Baltimore Convention Center. And then the local health department learned of this problem because the attendees called 311 service, the city's 311 service, and they reported their, of course, concern, sickness, maybe they were taken to the hospital, and this was another example of what happens when we don't cook things properly. And imagine this happening at a food safety conference. So this is a little bit of a problem. Another example is Peanut Corporation Association, Peanut Corporation of America. They knew of the presence of Salmonella enterica in peanuts, and they released the shipment. So this was mainly a cross-contamination problem, and this happened between September 2008 and March 2009, and across 46 states, 714 confirmed illnesses. So this is a huge outbreak, and 9 deaths. So this is very, very bad. And the people responsible for this were in prison or sentenced to prison for many years. And this has been the largest recall in US history, and a lot of products contaminated with, and a lot of companies that were or had this type of problem. So this is an example of how important like food safety and food sanitation is in the food processing industry. So let's talk about food safety. Sometimes we may mistake food safety with food quality, but they are different. So food safety is in charge of addressing hazards and eliminating or reducing them. We talked about biological, chemical, physical hazards, and reducing the risks of these hazards from occurring. And the idea of this is to make food safe for consumption and to avoid any type of health impact on consumers. On the other hand, food quality is more related with the specifications that we want our products to meet, either by regulation or by the manufacturer. So examples of food quality are like size, color, flavor, consistency, and texture. And we have talked a lot about how additives help us with food quality to have a consistency in many different quality attributes, and how this impacts consumers' likability of this type of products. And these type of specifications can be set by regulations, which we call the standards of identity, or also by the manufacturer. So each company has to have food safety objectives. They began being implemented in 2002, and the goal of these food safety objectives, or FSOs, is to ensure the maximum hazard level specified at consumption is not exceeded. So it has to be quantitative, verifiable, and technically feasible. So what this means is that if you identify the hazard, say for example, a microorganism, and then you have to define what's the maximum hazard level that you are going to consider in a specific food. And that's why you have to quantify it. So if it's a microorganism, maybe it's like X number of CFUs, which is colony-forming units per gram or per milliliter. So this depends on the product. It has to be verifiable, so we have to take samples and make sure that the company has to make sure that the microorganism is not present in their final product. And it also has to be technically feasible, which means that it has to be a method that if you're in a company or a manufacturing company, it has to be fast, it has to be accurate, so it has to meet many criteria. So these are the food safety objectives for companies, and they have to follow them. And the microorganism example was just one example. We can have many different food safety objectives depending on the type of company. Another type of quality or food safety system is what we call the good manufacturing practices, or GMPs. In 1969, the FDA published the regulations for basic food plant sanitation. In 1986, revised these regulations and expanded them, and they have different parts deal with the food plant sanitation in different aspects like general provisions, buildings and facilities, equipment, product and process controls, defect action levels. And nowadays they are known as current good manufacturing practices. So this is like the food safety, food sanitation plan that a company has, and it has to do with how a process is developed and what are the things that will accompany this process in terms of the food sanitation and safety. So how this applies to the buildings that are being used to process foods. How does this apply to the type of equipment? How often do we do maintenance in the equipment? How often do we clean them? And has also to do with product and process controls. And this means, and is more related with if we have a specific processing conditions, let's say a temperature, a time, how we verify that we are complying with what we established as our target temperature. How are we verifying that this is being met, and the defect action limits? So if there's defects in our final product, what are those limits, and how are we assuring that we are not exceeding these limits? So along with this, we have sanitation, and the goal of sanitation is to protect the health of consumers by preventing contamination. What are the benefits of a sanitation program? To increase product shelf life and minimize economic loss, and prevent the contamination with biological, chemical, and physical hazards, which we talked about earlier. And we have two types of sanitation. One is chemical, and chlorine is the most used sanitizing agent. We have hydrogen peroxide and quaternary ammonium compounds or mixture of these compounds. And we have non-chemical sanitations like UV light and steam. So these sanitation practices are very important in manufacturing companies, but also in food service. And this is different from cleaning, right? Say we're washing dishes. So normally we have, that's called cleaning. We wash the dishes with like soap, water, and then in food service like restaurants, there is a sanitation step. So that's an extra step to assure that we prevent the occurrence of any type of hazards. Then if we want to talk about other quality procedures, we can talk about standard operating procedures, and these are called SOPs. And they are based on good manufacturing practices. And these are like, so now we have our quality system. We know what we want to do. We know that we want to prevent X or Y hazard, but then we have to write it down and write a procedure, and that's why it's called a standard operating procedure. So we want our workers to know what they have to do, how they are going to do it, and how often. So some of these type of procedures are called the sanitation standard operating procedures, because we're talking about food sanitation, and depends on the sanitation program for each manufacturing plant. These SOPs are required by meat and poultry plants inspected by FSIS, or the Food Safety and Inspection Service in the USDA. So standard operating procedures are documents. Think of them about like a recipe of what a employee has to do. So let's say you are, for example, cooking a piece of meat, and you have to reach a specific temperature to serve it to the customer. So then the standard operating procedure will tell the employee like how do they have to cook it, how they have to measure the temperature, what that temperature is, and what will happen if they don't reach the temperature. What are the action plans? Are they going to discard it, or what is going to happen? So this is just an example of how companies have to prepare and what they have to do for our food to be safe. Okay, so at the beginning of the presentation, we talked about the types of hazards, and HACCP is one of the quality systems that is based on identifying what we call critical control points. It has been developed by previously established good manufacturing practices and sanitation standard operating procedures and SOPs, standard operating procedures. It is a system of 7 principles, and they are developed for a specific food type. So they are not generic for the entire facility, so they have to be developed, say, for example, for orange juice, for seafood. This quality system is based on identifying critical control points at specific stages of processing. So these principles are principle 1, hazard analysis; 2, determining critical control points; principle 3, critical limits; principle 4, monitoring procedures; 5, corrective actions; 6, verification procedures; and record keeping. So let me give you an example. Say I work in a restaurant and I have a seafood restaurant. So seafood is a type of food that is high in protein, and it's very susceptible to microbial contamination and hazards. So let's say I am receiving I have a supplier of fish, and when I am deciding I'm doing my hazard analysis, I determine that my critical control point is the temperature at which I receive this fish. So this is my critical control point. If the temperature is higher than what I established, I will have to decide what I'm going to do. So my critical limit is the temperature. So let's say I decide that the temperature is going to be 4 degrees Celsius plus minus 1. So my critical limit is going to be between 2 and 4 degrees Celsius. And this is just an example. We can have different types of limits. Let's say plus minus 0.5 degrees Celsius. So I defined as a company or as a restaurant what my limits are. So going back, let's say my limit is between 2 and 4 degrees Celsius. My ideal would be 3, but I have a range of what I will accept. So then I will go to the monitoring procedure. So I will ask my employees that in each batch that they receive for the supplier, they have to test for a temperature. And it is very important to know where to measure the temperature, because maybe the fish comes in ice, so the fish that is closer to the ice will have reached the temperature, but maybe the others will not. So in what part of the, let's say, cooler, I will check or monitor this temperature. So these procedures will tell my employees how to do it. And then this type of procedures will also tell them what the corrective actions are. So if I have a batch of fish, I check the temperature. The temperature is 3 degrees Celsius. It is within range, so I will accept it. But what happens if it is 5 degrees Celsius, 6 degrees Celsius? What is going to happen? What I'm going to do? Will I tell the supplier that I'm not going to accept the shipment? What I'm going to do? And those are the corrective actions. And this depends on the company. In some cases, in some other companies, you can, if the products don't meet the limits that are established, we can reprocess the product. In this case, it is very complicated because fish is so sensible to microorganisms contamination. So maybe in this case, we are going to say that our corrective action is, I will not accept the fish. And then the verification procedures is how often I'm going to be checking, as for example, as a supervisor, that my employees are monitoring these critical limits. And then record keeping is like where are they keeping track of this temperature. So normally we can build charts which we call control charts, or other types of graphical representations. And this is like, as a manager, I want to know like the history of the temperature that my fish arrives at my restaurant. So this is just a very basic example of how HACCP can be applied to a restaurant, but it is applied to many different types of processing facilities. Another type of food quality system, it's called the Food Safety Modernization Act, or FSMA, and this is was signed into law by Obama in 2010, and it's mainly related with fresh produce. And this is a response for data that was presented in which 48 million Americans suffer from foodborne illnesses per year. And it focuses on the prevention instead of the reaction of outbreaks. So we want to prevent outbreaks from happening, and we don't want to have a reactive approach, but to prevent them. And the FDA establishes enforcement tools that will help have these regulations in place. And also it enhances the ability to handle food imports. So this Safety Modernization Act is related with how our produce is produced. For example, what type of water is used to irrigate, say, for example, strawberries? Who handle our strawberries? How they were harvested? Were the employees or farmers healthy? So all these chain of like supply chain management or custody of, say, fresh products is verified by this Food Safety Modernization Act. And there's a lot more information. If you guys are interested, just look for FSMA. So what's the benefit for consumers with systems like FSMA? So it gives FDA the authority for recall. Before that, the only authority that was able to do a recall was manufacturers or distributors. And a recall is when you retrieve, when you discard, and when you pull out from the market something that you potentially think that has a hazard, mainly a biological hazard. It could be other types of hazard, but most of the times is microbiologically related. Also, the inspections are conducted using science-based risks, and it is important for the US because the US imports 15% of its food supply is imported. So all the countries or manufacturers around the world that want to export to the US have to follow these regulations. Also has the opportunity to have written plans and to prevent problems, and they use a lot of like scientific evidence to guide the documentation and to guide this prevention of outbreaks from happening. And also there's a respect for small businesses and farms, because there are exemptions. Depending on the type of business that you have to follow specific guidelines on how often you have to conduct specific types of tests related, for example, with water use for the production of crops, how crops are handled, and so pesticides and all that. So this is just a final slide from the Center for Disease Control and Food Safety at Home. And you can follow the link, but these are like the 4 steps to food safety, and they are clean, separate, cook, and chill. So clean, we know we have been talking about like cleaning, and in the case of food service and food processing, sanitation. Separate, so in food service mainly we have to separate the type of utensils or tools that we use to prepare different types of food. So meats are separated from vegetables, and so. So cook is, as I mentioned before, cooking temperature is so important to prevent food safety issues. And chill is how we store our products at what temperatures and temperature control. So I want you guys to start thinking about these different steps and start researching how the products you selected for your term project, how are they processed. We're going to talk during the next week about food processing and the different types of preservation or processing technologies, but start thinking about that. So my final questions are: what are examples of food hazards? Why are food safety objectives critical to define? What is food quality and how is it different from food safety? Are SOPs mandatory for all food processing plants? How did FISMAR help consumers? And how do certain foods need to be cooked? If you have any questions, please reach out.